On February the 6th, 2023, one of the most horrific catastrophes in modern history occurred in Turkey and Syria as a result of an earthquake with a magnitude of 7.8 and the subsequent destruction. More than 52,000 people lost their lives. So why is humankind still unable to predict such disasters? Scientists have been looking for certain earthquake patterns for a long time, but even when they find them, they can't always explain them. Back in 1961, geophysicist John Oliver discovered strange vibrations that occur in Earth's crust every 26 seconds. It's like the planet's deep pulse. What if that's the key to the worst earthquakes in history, like the recent ones in Turkey? And if we don't use it in time, will our Earth be bombarded with a global series of cataclysms without warning? Why does our planet vibrate every 26 seconds, and how can this be related to devastating catastrophes? It is logical to assume that immediately after John Oliver discovered strange vibrations, experts from all over the world rushed to search for some kind of an explanation, right? In reality, nothing like this happened. No one even tried to understand the issue because it was about microseisms. This is what they usually call low-frequency vibrations from 10 to 50 microhertz. This is 10,000 times lower than what humans can hear, even quieter than the swarming of bacteria on our skin. Such fluctuations in Earth's crust are so faint that they're absolutely safe for people, so most scientists felt that they had better things to do. However, 20 years later in 1980, Gary Holcomb, an employee of the U.S. Geological Survey, almost accidentally stumbled upon the mention of Oliver's microseisms. This time, he didn't ignore the discovery, but by doing additional research, showed that the mysterious 26-second vibrations had become stronger shortly before the storms. Holcomb's article would also likely have passed by the scientific community if Earth hadn't given people a powerful blow. In the same year, 1980, an earthquake of magnitude 7 occurred in California. It became one of the most powerful earthquakes in U.S. history. Around 7 a.m., when most of the locals were still asleep, the ground shook so hard that in just a few seconds, more than 3,000 buildings collapsed. Hundreds of people were trapped under the rubble, but it was almost impossible to help them because half of all the roads in the region were destroyed. For several days in the aftermath, Californians were left without electricity and water. They were forced to seek refuge in the surviving state buildings after losing their homes and property. Casualties were avoided only by a miracle, as the epicenter of the tremors was in the ocean. The sudden powerful earthquake spurred scientific research, but the mysterious vibrations of Earth's crust were again thrown out as too insignificant. The research was left on the shelf for 25 years, but even during this time, the frequency of vibrations didn't change. Strange impulses had been shaking the Earth all this time, and we would never have known about them if not for a graduate student, Gregory Benson, from the University of Colorado at Boulder. He decided to sort through old documents and accidentally ran across Holcomb's article. In search of an interesting topic for his scientific work, he decided to double-check the data and made a discovery. Benson managed not only to fix strange vibrations repeating every 26 seconds, but also to approximately determine their epicenter, which is in the Gulf of Guinea off the western coast of Africa. But skeptical colleagues didn't believe the graduate student. First, the researchers decided to double-check their devices to determine whether the vibrations could be caused by a simple malfunction. It soon became apparent that everything was normal with the seismometers. Then, scientists suggested that microseisms are the same as Earth's hum. Geologists use this term to mean constant background seismic activity, which doesn't depend on a particular region. Even without earthquakes, lab devices anywhere on our planet record slight fluctuations in Earth's crust. However, the frequency of this background noise turned out to be much lower than the 26-second vibrations. Moreover, unlike repetitive pulses, Earth's hum is chaotic. The discovery was confirmed, and subsequently, an article on the vibrations was published in the scientific journal Geophysical Research Letters. However, neither Benson nor his colleagues succeeded in explaining this phenomenon. Just imagine the despair of the researchers. Earth inexplicably shakes every 26 seconds, and from time to time, this seemingly harmless rhythm is accompanied by terrible earthquakes. The connection was somewhere there, yet in order to establish it, it was necessary to find the actual cause of the vibrations. In 2011, another graduate student managed to get closer to unveiling the mystery behind the vibrations. Garrett Euler from the Washington University lab in St. Louis identified a specific point where the impulses come from. This is the Bight of Bani in that same Gulf of Guinea. For many years, this place was considered the only epicenter of 26-second vibrations until in May of 2018, researchers found a second epicenter, a bay 50 kilometers from the east coast of Mayotte in the Indian Ocean. Hoping to finally unravel the seismological mystery, the scientists sent the research vessel Marion Dufresne there. Its crew had to constantly monitor the microseisms of the seabed. However, vibrations could soon be felt without ultra-precise measurements. In the next few years, after the signals were detected in this very region, more than 1,800 earthquakes occurred with a magnitude of 3.5 points and above. This directly led the researchers to the idea that impulses repeating every 26 seconds could be harbingers of major disasters. But why do the mysterious vibrations happen near the African coasts? At the Seismological Society of America conference in 2013, the same graduate student Garrett Euler, who first located the strange microseisms, suggested that they were due to normal ocean tides. As a rule, the movement of large bodies of water doesn't have a noticeable effect on the seabed, but when the waves repeatedly repeatedly hit the continental shelf, where the solid ground is much closer to the surface, the pressure deforms the bottom and can cause seismic impulses. In other words, when tidal waters collide with continents, land areas begin to vibrate like a bell. During storms, this effect is enhanced by reverberation, when the impulses are repeatedly reflected and feed each other. And off the coast of Africa, the solid continental shelf protrudes into the ocean the most. So, is that all? Or could microseisms still give science more? The key to predicting earthquakes. Moreover, seismic catastrophes have reached a new level in the last decade. On March the 11th, 2011, near the coast of Japan, an underwater megathrust earthquake with a magnitude of 9.1 occurred. This resulted in one of the most powerful tsunamis in modern history. Waves over 40 meters high covered settlements at a distance of up to 10 kilometers inland. Around 130,000 buildings were completely destroyed, and more than 900,000 were damaged. About 20,000 people died during the disaster, and more than 2,500 went missing. But even this wasn't the worst thing, because the tsunami caused by the earthquake damaged 3 reactors of the Fukushima 1 nuclear power plant. Within a few months, about 300 tons of seawater became saturated with radioactive waste. Studying the chain of events that led to this tragedy, some Japanese scientists seriously drew attention to microseisms repeating every 26 seconds. What if they could help prevent the next disaster? Indeed, right now, scientists are predicting a global series of earthquakes with a magnitude of at least 7 points, which should happen around 2032. But so far, no one can possibly give a more accurate forecast. Meanwhile, Garrett Euler's theory about the ebb and flow hasn't received clear evidence. After all, the African coasts aren't the only place on the globe where solid rock meets the ocean, but in other similar regions, mysterious vibrations are not observed. What if everything is much simpler? Considering that there's an entire ocean of red-hot magma beneath our feet, could it be that produces the mysterious microseisms? In the same 2011, in response to Garrett Euler's publication, a group of scientists from the Institute of Geodesy and Geophysics in Wuhan, China, led by Yingjie Shaw, suggested an alternative explanation. According to them, the vibrations that occur every 26 seconds are caused by ordinary volcanic activity. After all, both African epicenters of microseisms were in suspicious proximity to active underwater volcanoes. Moreover, this group of researchers could determine that one of the largest underwater volcanoes, Aso, on the Japanese coast, also produces periodic low-frequency vibrations. Could it have something to do with the terrible Fukushima disaster? The version of Chinese scientists began to look even more plausible after, in 2019, a researcher, Robin Lacasson, along with colleagues from the Physics Institute Globe de Paris, decided to continue the investigation on their own initiative. And near the source of vibrations in Mayotte, his team discovered an active underwater volcano. The rhythmic movement of molten rock under the sea bottom could easily explain the repetitive vibrations. Besides, such magma flows have already led to serious disasters. On the Canary island of La Palma, experts have long watched the unstable Cumbre Vieja volcano, which directly threatens much of the Atlantic Ocean basin. The average volcanic eruption lasts about a week and a half, but Cumbre Vieja loves long performances. Even its shortest eruption, dated 1971, lasted 25 days. But in recent years, it has sold out in earnest. In 2019, scientists discovered that the old volcano was producing a new vent near the village of Takande on the same island. This meant only one thing: too much magma accumulated, and it began to look for new options to reach the surface. As a result, on September 19th, 2021, the island of La Palma was shaken by a powerful eruption. Hot lava covered more than 10 square kilometers of territory, destroying more than 3,000 buildings. This disaster showed that volcanic eruptions can become a time bomb. Even though numerous victims were initially avoided, about 10,000 local residents suffered severely, including those affected by volcanic ash, which is extremely rich in chlorine, fluorine, and phosphorus. They can accumulate in the human body and lead to serious diseases. For example, to a severe form of pneumoconiosis, when a person's lungs are literally corroded by foreign particles. After the eruption of Cumbre Vieja, this disease was most often diagnosed among the inhabitants of the island of La Palma, and the same fate may be waiting for the inhabitants of the Indonesian island of Java. The start of 2023 turned out to be difficult, not only for the people of Turkey. After all, on March 11th in Indonesia, the eruption of Mount Merapi suddenly began. Now, the government is urgently evacuating more than 3,000 local residents because of dust and gas emissions. They can no longer stay in their homes. It would be great to be warned of such disasters in advance so as not to be exposed to the toxic effects of emissions. However, often volcanoes don't give any clues in the form of low-frequency vibrations, and in general, only a few of the thousands of registered underwater volcanoes produce any microseisms. So maybe scientists have been looking in the wrong place all this time, and instead of looking underground, they need to search for answers in the sky. It turns out that celestial bodies millions of kilometers away from us can influence terrestrial cataclysms. On other planets, this is common. Jupiter's moon Io is shaken by more than 10,000 earthquakes every year, and all of this is due to the super powerful gravity of the gas giant. But our Earth has a much more massive neighbor. On September 7th, 2021, 12 days before the eruption of the Cumbre Vieja volcano, on the other side of the world, in the Mexican town of Acapulco, an earthquake of magnitude 7 on the Richter scale struck. Tremors destroyed more than 8,500 buildings, affecting about 15,000 local residents. But it differed from other disasters because of fantastic anomaly. During the earthquake, people saw bright flashes of red and blue lights in the sky. The phenomenon was quickly dubbed the apocalypse on the internet, and some Mexicans even began to seriously prepare for Judgment Day. Of course, scientists weren't satisfied with this explanation, but they just didn't have another one. After all, the conditions conducive to the appearance of lights occurs in less than 0.5% of earthquakes around the world. They just didn't have time to study this phenomenon enough. Friedemann Freund, a senior scientist at NASA's Ames Research Center, has suggested that the mysterious lights could be caused by a piezoelectric effect. This means the compression of the rock leads to the formation of an electrical voltage. That is, stones colliding underground are capable of releasing such a bunch of energy that people can't observe it with their eyes. This effect is often produced by quartz rocks, one of the most abundant rocks on the globe. However, even with this knowledge, reproducing the lights under controlled laboratory conditions proved nearly impossible. This is because scientists haven't considered a key factor, and by that, I mean plasma emissions from our sun. The authors of a study published in Scientific Reports in July of 2020 argue that solar flares may well lead to earthquakes. They constantly inject a tremendous amount of energy into space as streams of protons and electrons, and although they don't penetrate into Earth's crust, the particles still make our planet vibrate. Scientists have noticed that when more particles hit Earth, earthquakes with a magnitude of 5.6 often occur the next day. First, protons crash into Earth's magnetic field and create electromagnetic currents that then propagate around the globe. Then these impulses charge the quartz rocks in Earth's crust, and they begin to tremble like leaves in the wind. In the most unstable places, this leads to earthquakes. It took scientists decades to discover this incredible connection. If we compare the data on earthquakes and solar activity over the past 20 years, it all adds up. Moreover, a team of scientists led by Giuseppe De Natale from the National Institute of Geophysics and Volcanology in Rome managed to trace another correlation. They found that the map of the regions directly affected by solar emissions coincides amazingly with the sources of the 26-second vibrations. The only thing is that the global piezoelectric effect can amplify the seismic phenomenon, but not cause it. Some experts have long been trying to predict disasters based on the location of celestial bodies in the solar system. Dutch researcher Frank Hogerbates has been doing this for more than 5 years, and it was he who managed to predict the epicenter and magnitude of the Turkish earthquake 3 days before it hit. However, when scientists took a closer look at Hogerbates' calculations, they found that they were as accurate as any horoscope. That is, too vague. Indeed, this researcher often indicates almost half of our entire planet is the epicenter, and some kind of disaster will undoubtedly happen on this vast territory. It's like saying someone will die in New York today. Such a prediction will certainly come true. Ultimately, the question of where 26-second vibrations come from and how they relate to seismic activity remains the subject of intense scientific debate. The solution seems so close, and at the same time, it's slipping away from us. Maybe close observations of mysterious vibrations on the eve of the apocalyptic 2032 will be able to give at least some hope of salvation. What do you think? But perhaps, with all its activities, humanity only makes the already unstable situation in Earth's crust even worse. A seismologist from the Royal Observatory of Belgium, Thomas Lecoq, found that during the coronavirus epidemic in 2020, Earth's seismic activity decreased by almost a third. Presumably, because more than half the population of our planet was sitting at home, the construction of subways, the drilling of wells, and the construction of huge highways completely stopped. Do you think it's our civilization that causes all of these disasters?